Hi everyone, and welcome to this review note. In this clip, we're going to look at an example of subnetting the third octet. I'm going to assume that you know how subnetting works and that you know how to subnet using easy math. If you don't, I encourage you to go back and review at least parts 2 and 3 from this video series. For our example, we're going to have a medium business, and here is our assigned network. We're going to assume, based on our design and our requirements, that we need 20 subnets. The largest one is going to have 900 wireless devices on it. So that's what we're going to have to work with as far as our design is concerned. Next part, how many of those host bits do we have to borrow in order to give us our 20 subnets? So we've got class B. Here for sure is our network. We have to borrow some host bits from here in order to give us our 20 subnets. What we can do is take 2 raised to the power of 5. That gives us 32, which is greater than the number of subnets that we need. That is the lowest that we can go. If we use 4 bits, then we'd have 2 to the power of 4, which is 16. That is not going to meet this requirement. How do we know which octet is subnetted? Again, pretty easy. We know that we've got 16 bits based on our given network. We've borrowed 5 to give us our 20 networks. If we add the 16 and the 5 together, that gives us 21. That is between 16 and 24, so it's going to be the third octet. And of course, that 21 is going to give us our CIDR value. So now how many host bits do we have left? Well, if we take 32, we subtract the 16 from our given network, we subtract the 5 that are required for the number of subnets, that's going to leave us with 11. And is that going to allow us to meet our requirements for our largest network? Well, 2 to the power of 11 less 2 is 2046, which easily will allow us to handle the 900 hosts that are going to be on our largest network. Next step, block size. So we know that we have a maximum of 32 subnets based on those 5 host bits that we borrowed. If we divide that 32 into 256, we get 8, and that's going to be our block size. With that, we can now figure out our subnet mask. We know, based on our given network, that the first 2 octets must be network. Therefore, 16 ones, divide those into octets and convert to decimal. We have 255 in each case. This third octet we don't know about. That's going to be part host and part network. And then our last octet is going to be 0 because it's all host. So what we do is we can take in that octet 256, subtract off the block size, that gives us 248 for the subnet mask value in that third octet, and hence there is our subnet mask. Let's get on to doing the network map. So we know that our first 2 octets are going to be network. That cannot change. That's our given network, assigned network. We know that the last octet here is going to be always 0 because that's going to represent host since we're subnetting the third octet, and the subnetted octet always starts at 0. So both of these guys are going to be 0, and there's our first network. In order to get to our next network, we simply add the block size to the subnetted octet. This octet here started off with 0, add the block size, we're now at 8. We keep doing that until we filled out all of our subnets. So 0, 8, 16, and I've done the last one, which is 248. Quick sanity check. When you look at the subnetted octet, the last octet should always be 256 less the subnet mask, which is less the block size, and that'll be equal to our subnet mask. How about broadcast addresses? Again, the broadcast address is always going to be 1 less than the next network. If we start with our first network, we look at the second one, the subnetted octet value is going to be 8 or 8.0. We subtract 1 from that, and we get 7.255. Same with all of the rest of our broadcast addresses. In the last case, if we take 248, we add 8, that's going to give us 256, which of course is invalid, it's too large, but we subtract 1 from that, we end up with 255.255. Again, quick sanity checks. The value of the third octet is always going to be 1 less than the next network value. The value of the fourth octet always going to be 255. How about that first host address, the valid host address in each one of our subnets? Again, we're going to have our network address, our subnet address, plus 1. We start with this. We add 1. That's going to be the least significant bit in the last octet. So we end up with 1. Again, quick sanity check. Every one of the third octet values is going to be the same as the network, 0088. And if I look at my last octet, it's always going to be 1. And we need to have the last valid host address. So if I take my broadcast address, I subtract 1 from that, which means that the fourth octet here is 255. The fourth octet here is 254. Again, quick sanity checks. The third octet is always going to be the same as the broadcast address, 1 less than the next network, and the last octet is always going to be 254. And it's that easy to come up with a network map and figure out what our network addresses are when we're subnetting the third octet. So wrap for this video. Hopefully this has been helpful for you, and we'll see you next time.